Assalamualaikum and welcome to our presentation. Today we are going to present application of logic in real life. So our project title is water dispenser. So these are the group members, and the one speaking is Muhammad Afnan Hanif bin Muhammad Nizan, and my ID is 2024432798. So these are the content that we will be discuss throughout the presentation. The first one is introduction, and then follow up to truth table, logic circuit, solution, and lastly summary. So what is mathematical logic? So logic is the study of reasoning. The reasoning may be legal opinion or mathematical confirmation. We apply certain logic in mathematics. Basic mathematical logic is negation, conjunction, and disjunction. Why we use mathematical logic? In real life, people always use logical thinking and reasoning in determining to prove the argument is valid or not. We can use logical thinking and reasoning to solve many problems in various fields. So these are the symbols for these are the symbol of a logical connective. The first one is negation. So the symbol is flow like this, and we can pronounce it as not. And then the second one is conjunction, and we use this symbol, and we use it as and. So the third one is disjunction. So in this symbol implies or. So implication is this arrow symbol, and it stands for if, then, if, and then statement, then. So this by conditional, there are two arrows, left and right. So it stands for if and only if. And now we're going to truth table. First one, a truth table is a mathematical table is used in logic which set out the truth value of the logical expression and their functional arguments. The truth table can be used to show whether a proposition is true for all legitimate input value, logically equivalence or logically implies. The truth table has one column for each proposition or input variable and one final column that show all of the possible result of the logical operation of the input variable. Each of the proposition will have two truth value, which is true, we can use T or 1, or false, we can use as F or 0. So this is the example of the truth table. So we use the input as A and B, kinda like A and B is like the button. So A is cold. So A is hot and B is cold. So in the first column for A, it has two value like truth, and false. So for B, choose true, false. For hot, true, false. Cold, true, false, and warm, true, false. So logically, when A is hot and B is hot, so true and true becomes hot. So for the cold, so true become true. So for warm, it's also true. So for the second, true false become true, and true false for cold become false, for warm become false. So the column false true becomes false, for cold become true, so for warm become false. So last column, false, for hot it become false, for cold become false, and for warm become false.
Next, we will talk about the logic circuit. First is a serial or series circuit. In a switching network, the connector N is used to represent the serial circuit. If terminal A and terminal B are connected to two switch P and Q in the serial, then switching network is represented by P and Q as shown in the figure. Next is a parallel circuit. In a switching network, the connector OR is used to represent the parallel circuit. If they are connected in parallel, then the switching network is represented by P or Q as shown in the figure. So this is the example. So this picture is show that how our water dispenser will be processed. So first, user will enter the input of button A and B, and then the logic circuit will process and will come up with the output whether cold water, hot water or warm water will be dispensed. So this is the condition. The first one, if we want off the water dispenser, the input A and B must be 0, 0, and then the water will not dispense. Next, for hot water, the input A will be 1 and input B will be 0, so only hot water will be dispensed. Next, for cold water, the input A will be 0 and input B will be 1, so only cold water will be dispensed. And lastly, for warm water, both A and B will be, for warm water, the input A and B must be 1, 1, so warm water will be dispensed.
So, hi, I'm Zarif. I will continue about our solution to dispense water. So, the construct that we use is A and B, or A and not B, equivalent to hot water. For input A, true, false, and B, true, false. Not B, false, true. A and B, true, false. A and not B, false, true, false. A and B, or A and not B, will be true, false. So the hot water will be dispensed because the output same like hot water. Since A and B, or A and not B, is equivalent to hot, the statement is true. Next. So this is our solution for cold water. A and B, or not A and B, equivalent to cold water. So for input A is true, false. For B, true, false. And for not A is false, true. A and B, true, false. Not A and B will be get false, true, false. A and B, or not A and B, true, false. Same like output for cold. So the water will be dispensed for cold water, true, false. Since A and B, or not A and B, is equivalent to cold water, so the statement will be true. And this is the last solution for warm water. We use A and B equivalent for warm water. A, true, false. For B, true, false. A and B will be true, false, and the output will same like warm water, true, false. Since A and B is equivalent to warm, the statement is true. In conclusion, application of logic is important in our life. Understanding the fundamental of logic enables us to approach in crucial situations. It also enables us to think logically and make better decisions to improve the outcome for some situation. Lastly, logic is not just a subject in mathematics. It is a tool for thinking clearly and living wisely. Whether we are choosing what to eat, making plans with friends, or solving real-world problems, we are applying the fundamentals of logic. I think that's all from our group. Thank you.